Hello all. So in today's video, we are going to learn about dynamic memory management functions in C and how they work. So as you can see, I have listed three functions here: malloc, calloc, and free. So malloc and calloc are used to allocate the memory, and free is used to free the memory, as the name suggests. So both of them are very similar in functionality. Uh, it's just that there's difference in terms of their signature, as in like what arguments they expect, and there is some difference as in their output as what they produce. So as you can see, calloc takes two arguments, n and size, and then it would produce n objects of size whatever is passed here, initialized all the blocks with 0. Whereas malloc doesn't do the initialization with 0 part, and it just takes one argument, that is the size in bytes. So we'll take two cases. First is, so we'll use malloc for all our examples, and you can easily convert malloc to calloc. So we'll see how to initialize uh, 1D array, and then we'll see how to initialize a 2D array using malloc. Okay, so as you can see, like malloc takes the size in bytes as how many bytes we want to reserve, and then it returns a void pointer. So how we can use this is, I would just call malloc. So assuming like we have to initialize an array of size 5, okay, 1D array of size 5. What I will do is I will say malloc, and then I will say 5 times size of int. Okay, this would give me enough number of bytes. This is my number of bytes that I want to reserve. But I also remember that malloc returns a void pointer. So what do we want? Like we want to typecast it into the appropriate type of memory that we want to use. Okay, so here like I would just typecast it into an integer point. Okay, and then we can use any pointer variable here. So int star p. Okay, and this statement would basically allocate 5 blocks in memory anywhere. So let's say 100, then 104, 108, 112, and 116, and then it won't do any initialization, and it would return the base address into p. So p would now contain 100. So that's it. So is the same thing. We can use this array just like the array which we created using like statically. That is like if I do something like this, um, uh, 5, or let's change the variable name. I'll show you why. I'll show you why. Int a5 is equal to, let's say I initialize it with some random values, and then I can again do the same thing. Okay, so this thing is very similar to this part. Okay, so that's how you initialize a 1D array. Now let's move on to the second part, initializing a 2D array. How will do it? Let's see. Uh, so remember, 2D array is array of arrays, and we just learned like how to initialize a 1D array. So whenever we have to initialize a 2D array, we'll see how many 1D arrays we need. And then we'll initialize those many 1D arrays, and then we'll keep the base address for each of those in another array, which to in another array, and that's how like it would be created as a two-dimensional array. So what I mean is, let's say I have to create a 2D array of size 3 by 4. Okay, so let's say I have to do in let's say a 3 cross 4 size array. So how many one-dimensional arrays are there? So if you see this, like there would be like 3 one-dimensional arrays, right, of size 4. 1, 2, 3. So what I would do here is I would create these one-dimensional arrays, okay, of length 4. And how many of those we need? We need 3 of those, right? If I have to create a 3 by 4 array. So we would, so my plan is to create three one-dimensional arrays. Okay, pardon me for my writing. And then what I'm going to do is I'm going to store the base addresses of all of these. So for example, now let's say this starts from 100, this starts from 200, and this starts from 300. What I want to do next is I want to hold the addresses, base addresses of all of these, and how many of them they are. So there are three one-dimensional addresses, so we would need three spaces, right? Three. This one should contain 100, this one should contain 200, and this one should contain 300. Okay, so basically this one points here, this one points here, and this one points here. Now I have a 3 by 4 array initialized, and I know all the base addresses of all of those three one-dimensional arrays, each of them having size 4. What I have to do is I need to have some way to access this location, right? If I know this location, I know this location, I know this location, okay, so I can traverse the entire array. So what I would do is I would create okay, one more thing. What would be the type of these? So assuming we have to create a 2D integer array, all of these would be of so all of these would be of int array, right? Uh, what about this thing? What would be the type of this array? This would be of int star pointer, right? So basically an array of int stars, int pointers. So each of them stores an address to an integer pointer, right? And if I have to access this location, what I have to create just one more variable, right? Because like this is just one base address. So what I would do is, and now what would be the type? What would be the type of this pointer? So this is some kind of pointer. What would be the type? This pointer points to a location, a pointer which contains, I mean, this pointer points to another pointer which points to integer, right? So this is two level of pointer. So this would be of type star star p or whatever name you might want to give. So that's what my plan is. Okay, let's see. So let's see how we'll do it. So first of all, int, as I said, like this one would be a two-dimensional pointer. So ptr again, let's see. And then what I would do is how many I would need, how many one-dimensional array addresses I need. So if I have to create a 3 by 4 2D array, I need three one-dimensional addresses, right? And so this would be, so we need to hold the address for three one-dimensional arrays. So size would be 3, right? And again, like I have to typecast anyways, so I'm writing this first. And then malloc. Okay, let me write it on the other line so that it is clear. Malloc, and then 3 times size of int star. Okay, so this one would, so this is what we learned, right? How to create this is just like creating a one-dimensional array, this array. Okay, I'm reserving 3 blocks. Each block would can hold an integer pointer, and then I'm storing the base address of that block in this variable ptr. So this is my ptr. Okay, now what I have to do, for each of these addresses, I need to create a one-dimensional array, right? And then I want to store the addresses of the base address of each of those one-dimensional array in this array. Okay, so let's do it. So we'll have to use a loop. So what we'll do is for I int I equals 0, I less than 3, and we're just looping through it. What I would do is ptr of I equals, now I have to create one-dimensional array again, right? Like now I'm up to creating these arrays. So what I would do, I would just say, okay, one-dimensional array is just a single pointer, int star, and then I would do malloc, and what would be the size? 3 by 4, right? We wanted 3 by 4. So for 3 by 4, I have to use 4 times size of int, right? Now each of those blocks would be holding an integer. So yeah, that is it. I think this would do the trick for us. Okay, and just looking at one more time, so the first loop would create something like this, and then it would store it at some random location, and then it would just store the base address, and we are just keeping the base address in ptr of I, right? What ptr of now in the next iteration, what would happen is like another 4 size array would be created, and the base address would be stored at this position. Okay, and then another one, and this would be stored here. So that's how it would work. So now you can see we have created 3 one-dimensional arrays here. Each one has size 4. Okay. Yeah. Moving on to the last part. Still, all these array indexing would work for me, right? So ptr1, 2. This would still work. Why? This would get converted to star of ptr plus 1, and then star of plus 2. Okay, and this one ptr would give me 1000, right? 1000 plus 1 times size of int pointer, right? Size of int pointer. So this is size of int pointer, and then plus 2. Okay, so this one would give me how much? 1004, right? Star of 1004. So there is a star here as well, right? Star of 1004, and then plus 2, and then 1 star outside. Next, what is star of 1004? Let's see. Star of 1004 would take me to this location, right? This array, right? Let's number these one as well. 300, 304, and for the rest. 500, 504. Okay. So star of 1004 would give me another address, but this would be an array of one dimension, right? So this would be like 300 according to our diagram, and then plus 2. Now we have used one level of indirection. For another one, like now we have, what will be the size of the data type? Now it's an integer array, right? So it's an int. So size of int, or whatever that is, like 4. So 2 cross 4. So value at 300, and then 308 plus 8. Okay, so what is 308? This one, right? So if you see, this is same what we got, right? ptr1, 2 is correct, right? We are still able to access this value using the normal array indexing. So let's see some programs. Okay, so this is the first program just to demonstrate. So here I am just trying to create a 2-dimensional array. As you can see, I'm trying to create a 3 by 4 array, and the code is same to what I have explained previously. Here I'm just trying to store some values, and then trying to print out some of the values just to show you guys that everything is working as expected. Okay, so let's see. Okay, so it compiles fine, and then I'll just run it. So as you can see, it's working just like a normal array. Okay, now you could ask, what is the difference between allocating a 2D array like this and allocating it like a normal, like the static way, right? Like something like this, int a 3 4. This also we would have done, right? But what is the difference? The difference is the difference is the memory where both of these would get initialized. So what do I mean by that? So whenever our memory is separated by different memory areas, right? There is stack, there is heap, there are other memory areas as well. Whenever a function returns, whatever variable we declare statically uh, inside a function, that memory gets deallocated once the function returns. Okay, but that's not true for heap. So this whatever memory we are allocating through malloc and calloc, these are created on heap. So these won't be destroyed after the function returns. So let's demo this with the help of a program. I have created this another program to just to demonstrate that. Okay, so let's first, like, here what I'm trying to do is I would first create an array, like a local variable, and I'm trying to create an array on the stack. Okay, using like normal method. And then what I'm trying to do is I'm trying to call this function here in main and trying to store. So this one later I'm returning the base address of the array. So if this, and then I'm trying to print the values stored in that array. So let's see what happens when I'm trying to do this. Okay. So you see, there is a warning. Address of stack memory associated with local variable B is returned. Okay, and this is a warning. In some compilers, you will get an error. So if you try to print this one, what happens is, so see what values we have stored. Okay, so we have not stored any value here. So let me just do this and then we'll see what happens, whether this works correctly or not. Okay. Okay, so the warning, and let's try to run it now. So you see, here we are storing I plus 1. So ideally it should be like 1, 2, 3 value should be stored in B, right? But what happens here, like there is some garbage value, right? Why? Because the memory was freed. This B, whatever block of memory was allocated with this statement when this function was called, gets freed when this statement is encountered, return B, and then the function returns, right? And when we are trying to print it, this is the point where, I mean, before this point, the memory has already been destroyed. So it's just printing some random values here. Okay. But because like this was created on stack, and stack memory gets destroyed whenever the function returns. But that's not the case with heap. Okay, so let's see. I'm trying to create a same one-dimensional array using malloc, and malloc would create the memory on the heap area. Okay, and then I'm just trying to write some values and then I'm returning the base address. So now let's try to compile this. Okay, so you see, like there's no warning. That means the variable is not created on stack. This is somewhere else. Like this is on heap, and heap memory does not gets destroyed when the function returns. So this one would work just perfectly. Okay, so calloc and free I'm not going to demonstrate because calloc is just, calloc would do the same thing we already discussed, and free is nothing. Like free, you can, is just to release the memory. So they are very, very simple and you can just follow on using this tutorial. So thanks all for this video. Thank you.